Hello everyone, my name is Raza Ul Mustafa and I will present Dash QE framework and prediction in 5G networks. Online video streaming has become the most dominant application of today's internet. Video streaming becoming very popular and sites such as YouTube, Netflix accumulate nice share of internet traffic. 5G is expected to support high throughput and low delay, contributing to enhanced quality of experience expectations. One of the key challenges in 5G is adapting to the increased growth of video streaming traffic and maintaining smooth QoE. Streaming services adopt Dash paradigm to deliver online video contents. Adaptive streaming algorithms aim to detect a favorable quality of video streaming using network status QoS, delay throughput loss, and provide error-free video quality. In the future 5G future network, QoE management is crucial to optimize better video delivery. It is necessary to understand the ABS algorithms behavior, the impact and correlation between QoE and QoS KPIs. What is logic behind Dash? Dash works by split video file into many small segments, 2 to 10 seconds. Each segment coded with different bitrate and resolutions. The representation of each segment described in an MPD file. ABS algorithms are responsible for dynamically selecting the appropriate segment based on the current network condition. If network condition very good, then the ABS algorithm select a segment with high resolution and high bit rate and hence high quality of experience. ABS algorithms are of three types: rate based, buffer based, and hybrid. What is purpose and contribution of this part? Provide a reproducible Dash framework with a series of pre-installed Dash tools. We provide interactive Jupyter Notebook and Binder service, providing an executable live analytical environment to process the output dataset of the framework, analyze QoE and QoS KPIs. We provide a machine learning classifier to estimate QoE based on RTT, number of packets, and throughput. Examine in-depth analysis of six state-of-art ABS algorithm, streaming with varying bandwidth, static, and mobility 5G scenarios. The framework has three phases: data acquisition, data preprocessing, and data analysis. The framework contains mininet Wi-Fi, caddy, Go-Dash player, TCP DAS, and few scripts to parse Go-Dash log files and PCAPs. In the first phase, we have two switches connected to each other. We have a caddy server here, and we use 5G datasets traces and to emulate at this link. We have multiple Go-Dash clients streamed from the same server. We have caddy server here and we use animated video named Synta encoded using H.264. Segment duration we use a 2 segment contain each resolution with across 30 representation rates. We use 6 state-of-art ABS algorithms: arbiter, elastic, throughput, conventional, exponential, and BBN logistic at this point. During each experiment, Go-Dash player generate a Go-Dash log file which have these features, and these are objective QA APIs, and then this quality of experience model P.1203 create diamond gene and U. We use TCP dumps to collect pcap at this point. We use 10 different scenarios of driving and statics of in using 5G datasets collected from this point. We have 0.53 Mbps, 6 to 14 Mbps, 38 to 10 Mbps, and 29 to 10 Mbps. In case of static, we have 0.5 to 6, 8 to 57, 4 to 7.6, 52 to 0.5, and 7 to 20, and so on. We use Linux TC-Link. Bandwidth changes after every 4 seconds at this point. Stage 2 preprocessing. At this phase, we process per segment QE, QoS logs from stored Go-Dash logs and PCAPs, and we fetch per segment QoS KPIs from PCAPs using Python Scapy package. We fetch per segment QE KPIs from the Go-Dash log files, and we merge both. In the final phase, we analyze the dataset generated in phase 1 using a Jupyter notebook. For each segment in video session notebook, we provide 5 QE model output, 7 objective QE KPIs, and 3 QS KPIs, uplink RTT, download downlink throughput, and packets. We uploaded all the dataset on the GitHub and you can play with the dataset using interactive widgets. Finally, we provide a framework which includes in a VM with all the software and dependencies installed. The VM provides all tools and the environment needed to stream dash content for multi-user with realistic 5G network trace. For ease of use, the framework integrates the provided VM with Jupyter Lab. We also provide a video instruction on how to use the VM, and the framework link is available on GitHub at this link. Finally, we have QA prediction. We input the model RTT throughput and packets and predict and the model predicts P.1203 QE. We can see that we have a continuous value 1.8, 1.890 and so on, and we use these three features. So for these continuous values we use regression models to predict this value. We use three classifier multilinear regression, decision tree and NFRS, and for the accuracy of model we use mean absolute error. First we have results by ABS. By ABS type we have a hybrid, arbiter and elastic. Then we have buffer based and conventional in each case random forest regression have less mean absolute error as compared to decision tree regression and multilinear regression. Then we have case results by static and probability scenarios. And during these two cases, and again random forest regression have much better accuracy as compared to decision tree multilinear regression. Finally, we have the ABS analysis. We have hybrid elastic and arbiter, BBA buffer and logistic, throughput, conventional explanation. And the results I will show in next slide. We use two concurrent clients and first experience shown 60 segments for 2 minute video. Scientalink video we have used and per video segment we showed RTT, stars and P.1203 MO score. And we use the driving mobility case 0.5 to 3 Mbps, 6 to 14 Mbps. First we have QS RTTs in ABS. We can see that only logistic experience power RTT in case of 6 to 14 Mbps and also in case of 0.53 Mbps, and all other algorithms behave similar. Then we have stall and we can see only arbiter plus experience more stall as compared to other algorithms. And then we have QoE P.1203. We can see that arbiter have less QoE as compared to other ABS algorithm. And at this point from 40, we for the stall causes we can see from here the stall causes to switch the segments to the lower P.1203 values. We use ML train an algorithm agnostic classifier that predicts user QE using only network QoS matrix, RTT, number of packets, and measure throughput. Then we also provide a reproducible framework and live analytical environment to generate, process, analyze the per segment QoS QA KPI for dash experiment using different state of ABS algorithms. Thank you.